We'll start doing some practice problems now. If you have any questions you want me to cover, just paste them in the chat. Otherwise, I'll run through some random practice problems for the next 10 to 15 minutes. Okay, so a big thing for the next exam and intro, at least, is going to be these element symbols. And moving forward throughout the class, we're going to have these memorized. So just some practice here for naming these elements based on their symbol. SC, one of the ones you have to memorize. It sort of in the third column of the periodic table, it's the first transition metal. We'll get to what that means later. But basically, we have to memorize that this SC is scandium. Okay, so print out the periodic table that I provided online so that you can use that one to study, and it helps to memorize these and their location on the periodic table sort of helps reinforce that. So that one's scandium. These two I put on here because they're often confused. So AS, you can look at the periodic table, and that is on the right side of the periodic table, about sort of the center of the periodic table on the right side. AS is arsenic. Okay. And AT is a little bit to the right of arsenic and a little bit further down, element number 85. Astatine. And this is going to be different even than argon, right? So a lot of times this one's arsenic is confused with AR, but that's actually argon, and that's a noble gas in that last column. Okay, so these are the types of questions you can expect, so definitely put in the work to memorize these element symbols. Okay, this one's one I definitely wanted to do. It might come up in your homework, it might not, depending on what homework you have, but it is a more challenging type of problem that we haven't exactly done in class. We've done some similar to this, so I wanted to go through this isotope question here. And all we're told is carbon-12 has an atomic mass of 12 AMU. Carbon-13 has an atomic mass of 13.000 AMU. If the periodic table lists the average atomic mass as 12.0107 AMU, what are the percentage abundance of each isotope? Okay, so we're sort of assuming here that these are the only two isotopes of carbon. Technically, that's not correct, but for the sake of this problem, let's assume those are the only two isotopes. Okay, so that those two together account for 100% of the isotopes. The atomic mass listed on the periodic table is this weighted average that we talked about in class. Okay, and the formula for a weighted average is the percent of that certain isotope multiplied by its individual atomic mass. Yeah, to answer a question in the chat, the element questions will be multiple choice. Just to go back to this question really quick. The next exam will be all multiple choice. So, but I'm going to give you the symbol like AT, and some of the choices are going to be arsenic, argon, astatine, right? It's not going to always be super obvious that only one starts with an A. But yeah, it's not going to be fill in the blank, so you don't really have to worry about spelling too much. So good question on that. It will just be multiple choice. Okay, so this carbon-12 and carbon-13 problem, those are the only two isotopes. We know the average atomic mass, right, formula, is the mass of carbon-12 times the percent of carbon-12 plus the mass of carbon-13 times the percent of carbon-13. Okay, so go back through the slides if you don't recall that formula. There's an example for gallium. We did a couple other practice problems, or go to the textbook for that formula. But basically, this average atomic mass equals mass of isotope 1 in AMU okay, times the percent of isotope 1. So I'll just write out generally what we're looking for here. Carbon 12 AMU times percent carbon 12 plus the analogous thing for carbon 13. So carbon 13's AMU, which we're given in the problem, times the percent carbon 13. Welcome, Gage. So this is the overall formula. We're given some of these pieces of information here. 12 AMU is what we're going to put right here. That's the mass of carbon 12. Mass of carbon 13 is this 13 AMU. And we need to identify the percent of each, so this one and this one. Okay, so this looks a little tricky, but also keep in mind that we know that the percent of carbon 12 plus the percent of carbon 13 equals 100%. Okay, so in algebra, we would say this is two different equations with two different unknowns, which means it's solvable. And the thing we do then is, try to eliminate and express one of these unknowns in terms of the other. Okay, so the way this actually looks is we're not going to operate in percentages. We're going to operate in the decimal format here. So, you can take these percentages and divide them by 100, right? Sometimes you can just do that in your head, right? 50% is just 0.50. But in any case, in the formula I'm going to set up here, I need to have those in decimal format. Okay, so substituting in now 12.0107 equals this mass of carbon 12, 12.000. Okay. Multiplied by, what that little asterisk there means. And I'm going to call the percentage of carbon 12 here in decimal format X. Plus the mass of carbon 13, 13.000. Times the percentage of carbon 13 in decimal format. But I know carbon 12 plus carbon 13 in decimals should add to 1, just like in percentages should add up to 100%. So if carbon 12 is X, then carbon 13 is 1 minus X. Right? If carbon 12 is 90% or 0.9, then carbon 13 is 10% or 0.1. Okay, and so now we have a single equation here expressed in terms of this single unknown X. All right, so do take some time to understand this type of problem and how to set it up. And now you have to go through and solve for X. Okay, you have to distribute this 13 into the parentheses here. 13 times 1 is 13. And I'm going to drop the zeros. Well, nah, I'll keep them explicit. So I'm distributing this into the parentheses. 13 times 1 is 13 minus 13 times X. Okay, so I've showed you there how I distributed that. I'm just going to write out the rest of the information here, the rest of my equation. Okay, and so now I have 12.0107 equals 12x plus 13 minus 13x. I'm going to combine the like terms here. 12x minus 13x. You end up with negative 1x. Okay, so I'm going to move this. See, I probably can just go to a separate slide here. 12.0107 equals 12x. And I'll drop the zeros here just to make it easier or quicker. But I'll remember they're there if I want to worry about sig figs later. So this is the formula I got after I distributed that 13. Okay. Simplifying the right side, I can combine that 12x and 13x. 12x minus 13x, you're left with minus 1x. I still have the 13 sitting here, so don't forget about that. But this right side simplifies to 13 minus x. Okay, right, here's the 13 minus 13x, but I've taken away 12 of those x's. And so I should be left with 1x. That's negative, so 13 minus x on the right. Okay, so now I can isolate x. I can subtract 13 from both sides. And now on the left side, I get negative 0.9893. And that equals minus x. I can just, both sides are negative, so you can multiply both sides by -1 or whatever. The negative signs cancel. Basically, x equals 0.9893. Now, what was x? I specified x as the fraction of carbon-12. Okay, so x is the fraction in decimal format of carbon-12, 0.9893. Right, which means that carbon-13 is 1 minus x. So 1 minus x would give me 0.0107. Okay, and so in decimal form, that's my final answer. If I wanted in percentage form, I obviously multiply each of these by 100. So carbon-12 is 98.93% in this example. And this carbon-13 is 1.07%. All right, so that's a pretty rigorous problem here. All right, but as long as you're sticking to the formula for how to set these things up, keep in mind you have to also work with the decimal format. Don't operate in percentages. It overcomplicates it. And the math is easy to mess up if you're not careful. So I'd recommend using this x and 1 minus x kind of setup. Just remember what you're defining as x. Here it was carbon-12, so I know the x I get at the end here is for carbon-12. Okay, any questions on that? Post them in the chat. So that's about as hard as these isotope ones get. Right, you're always going to be given a couple pieces of information and asked to solve for another. Okay, hopefully that one doesn't make you cry too much with how difficult it is. All right. Let's move on to a quicker problem. How many atoms of each element are in the following compounds? Okay, and this is, again, another way to test whether we remember element names, just sort of test ourselves. And the first one here, Na, is sodium. And there's 3 atoms of sodium there. P is phosphorus. 1 atom of phosphorus in this formula, right? The 1 is implied here. We don't really write it. And oxygen, O, there's 4 atoms here. Okay, these can get a little bit more difficult when we have the parentheses. Remember, those parentheses are there to tell us that that OH is more or less a single unit in the molecule. And there's 3 of those OH units. okay, that are attached to a central aluminum atom. Okay, so Al is aluminum. There's one of those. Oxygen. There's one in each unit here, right? That one's implied, but there's 3 of the units, so we multiply this subscript out here by the subscript inside. So 3 times 1 is 3. There's 3 oxygens. And likewise, there's 3 H's, where H is hydrogen. All right, finally, Ga, gallium. 2 of those. S is sulfur. Again, multiply outside by inside. Inside S is implied to be 1, so 3 times 1 is 3. And oxygen here, O, 3 times 4 is 12. All right, that's really the only practice problems I prepared. I'll do a couple others here, just sort of on the fly. But if you have any questions about the last exam or this material, or open up your homework and ask questions from that, we can go through that. Okay, here's a couple other chapter 3 type problems. Physical or chemical properties we talked about in the latter stages of chapter 3. Right, physical is something, about the appearance, right? The color of, your eyes, something like that. The shininess of a metal. So this first one is clearly physical. Copper is shiny. Right? The mass or the density of a given amount of material, physical. Copper has a high melting point, so this kind of sounds like a chemical change because it melting point, that's certainly something we think of as chemistry and chemical, but you know, you're not changing the substance. It's still copper that is just going from solid to liquid phase, right? Phase change is always just a physical change, and so this is a physical property that its melting point is so high. Okay, the third one here, copper conducts heat well. Okay, the property of copper, right? When you have a copper pan and you put it on the stove, it quickly heats up. Okay, kind of like the phase change where you're, you know, adding heat to it until it melts. The fact that it conducts that heat very well is just a physical phenomenon or physical property of that individual element, copper. And the last one, copper reacts with oxygen. This is a dead giveaway. Anytime you see reacts with something else, right, that's a chemical reaction, so that's always going to be chemical. Okay, so remember the giveaways for chemical are reacts or flammable, right, or lights on fire, something involving a flame, you know, or burning is going to be chemical change or chemical property. You know, like hydrogen is flammable. Okay, it can be a chemical property. Chemical change, as you'll notice, you know, if a solution starts bubbling when you throw another element in it, right? Like if you toss magnesium into water, it'll start bubbling, and that's a chemical reaction. So it's a chemical property that magnesium bubbles when added to water, for instance, or sodium bubbles when added to water. So bubbling or evolving gas, or if it gives off heat once you combine two elements, that's signifies a chemical change, okay, or a permanent color change. Right, so burning and flammability is also sort of a key word for a chemical change. Okay, next problem, identify which of the following are metals, nonmetals, or semi-metals. Again, you're going to have a certain periodic table on the exam. Identify where these elements are. The things on the left of the periodic table are all metals. Okay, the left sort of up to that staircase, right on the right side, there's this certain element staircase we talked about of semi-metals. Right, things like boron live on the staircase, and silicon, okay, which are semi-metals. To the left of that are metals. To the right of that staircase of semi-metals are non-metals. So Tc, we can identify and look in the periodic table. It's smack dab in the middle, number 43. Okay, that's clearly to the left of this staircase. That's a metal. And everything in that sort of middle section of the periodic table are called transition metals. They're all metals. Te, I can look, and that lives on this staircase that we talked about, right? Sort of down into the right of silicon, a couple spots. Okay, but that is on this staircase. I would just memorize this staircase of semi-metals. Okay, you're going to get that color-coded periodic table that's on Canvas, so print that out and realize what color-coded section, although it's probably going to be black and white on the exam, but use that to sort of memorize where those semi-metals are. Okay, so Te is on that staircase, right? That's tellurium, and will be a semi-metal. Xe is on the far right-hand side, the very last column of the periodic table. Those are all non-metals. And just to go on and sort of test, I think in chapter 3, they have the periodic table presented in terms of metals and nonmetals, like in the front cover of your book, but then I think they also do it in terms of physical state. Yeah, so on page 74 of the book, they also present it as physical state, solid, liquids, gas. So you could also be asked something like this, are these solid, liquids, or gases? At room temperature, for liquids, remember there's only two, mercury, Hg, and bromine, Br. Those are the only liquids. Okay, the gases are the last column of noble gases, which is xenon is 1. That's a gas. And then there's a couple more, like nitrogen, oxygen, fluorine, chlorine, that are gases. Everything else is solid. So these top two here are going to be solids. Okay, so you can have questions like that as well. Yeah, question in the chat, you can drop by at 4 o'clock today is fine. Well, 4 o'clock will work just fine. Otherwise, yeah, you can come by tomorrow to my office hours, 1:15 to 2:45. That would work fine too. All right, so those are only questions I prepared, practice problems. So I'll stop the recording here and upload these practice problems to YouTube just so you can watch them later on if you want. Otherwise, I'll stick around for the remainder of office hours and answer any other questions you have.